Welcome to True Projects. In this video, we are going to explain about the project that is a novel framework for an intrusion detection system using multiple feature selection methods based on deep learning. Before getting into the execution, first let us understand what is the project about. You know how everything around us is getting connected to the internet? That may be phones, TVs, fridges, or even cars. While it is super convenient, it also opens up a whole new set of problems. More devices means more ways for hackers or malicious software to sneak in and mess with the systems. These threats can compromise sensitive information, disrupt services, and also basically cause a lot of trouble. Here where intrusion detection systems comes into the play. Think of them like security guards for a network. They monitor all the incoming data, try to figure out if there is anything is suspicious like someone trying to break or mess with the system. But here the problem is modern networks are insanely they're complex. There is so much data flowing with so many different parameters to check. It is overwhelming for these systems. It is like asking a guard to check thousands of people at once. Some details might be missed or the process slows down. So here the big challenge is figuring out which parameters are actually important for detecting threats. If we can narrow it down to just the essential details, ideas can work faster and more efficiently without wasting resources or unnecessary stuff. That is core issue in this project. And here, you know that intrusion detection system is like security guards. Well, they are getting smarter thanks to machine learning. Machine learning is basically helps these systems analyze patterns and make decisions way more effectively than older methods. But here the problem is machine learning works best when you feed it the right data. Imagine trying to find a specific book in a huge library without guidance. It's a chaos, right? So that's what happens if you give ideas too much unnecessary data to process. So this is where feature selection comes in. So this is where feature selection comes in. It is crucial to select only the most relevant parameters from the data, and this process is called feature selection. By narrowing down to the most relevant parameters, machine learning models they can operate faster and more accurately, and the system becomes way more efficient. However, However, traditional ideas, that is intrusion detection systems, they still face challenges like generating too many false alarms or struggling to detect new and evolving threats. To address these issues, the focus needs to be on creating better framework that one that combines effective feature selection with optimized machine learning models to enhance the overall performance. To overcome with all these issues, this project designs a framework to make intrusion detection system more efficient and accurate. What it does is it combines multiple feature selection techniques. So here multiple feature selection techniques have been incorporated, which are filter based and wrapper based. ANOVA feature selection technique is used. Mutual info, that is MI, has been used. Chi-square feature selection has been used. So all individual feature selection techniques have been used and selected. All the individual techniques, they will be selecting the important features according to their functionality. So after selecting the important features individually, all the features selected by these models will be aggregated. So all that will be aggregated into one more set that is called as feature set. Once these techniques are applied, the system assigns scores to the features based on how they are selected as important across the different methods. So this process helps create a smaller, more optimized data set, that is optimized set of features that are highly relevant for detecting threats, cutting out the unnecessary data and improving both the speed and also the accuracy of ideas. Once we have selected the most relevant features, next step is training different machine learning models. So here we train different machine learning models, which are decision trees, random forest, XGBoost, KNN, logistic regression, naive based, and AdaBoost. So the idea is to test these models with the optimized feature set to ensure the system performs with high accuracy while keeping false positive rate low. And for testing, we have used a dataset that is software defined networking IoT dataset. So we have used this software defined networking IoT space dataset. Even though the number of features were reduced, the system managed to improve both the accuracy and efficiency significantly. This shows that by focusing on the most important features and leveraging multiple classifiers, the framework becomes not only faster but also more reliable at detecting network intrusions. So this is about the proposed system. To further improve the performance, we have incorporated voting classifier, which is an ensemble model. So what it does is it combines predictions from multiple machine learning models. Each model contributes its own strength to the decision making process, and by combining them, the final prediction becomes more accurate and reliable. It's like taking a vote among experts. This way, the system becomes more robust and reduces the errors. And we have developed front-end using Flask framework. This makes it easy for users to interact with the system, test it, and provide input. To ensure security, user authentication was added so only authorized individuals can access the system. This combination of improved prediction accuracy and a user-friendly, secure front-end makes the system more practical and also accessible. Now coming to the implementation, to implement this project, we have followed these steps mentioned in the flow of work. So let us understand each step. Let us understand how did we implement the project. So the first step involves importing all the necessary libraries and packages required for data processing, visualization, model building, and evaluation. So we have imported NumPy, Pandas, scikit-learn, etc. Then comes exploring the dataset part. So your dataset is examined to understand its structure, distribution, and any potential issues like missing or inconsistent data. Then comes data processing. Here, duplicate rows are removed to prevent the redundancy. And unnecessary columns or irrelevant data is dropped to streamline the dataset. Then we visualize the dataset. Various plots, charts are generated to explore relationship, trends, and patterns within the dataset. Then we convert all categorical features into the numerical features, numerical values using label encoding technique because they will be suitable for machine learning models because only machine learning takes the numerical input, not the categorical input. Then comes feature selection part. So here we have selected features using different techniques. So we have used filter based and wrapper based method, and we have also considered ANOVA. This identifies features within significant variance, and then we have considered mutual information. This measures the dependency between features and target. And the last feature selection technique is chi-square test. It evaluates the independence of the features. So from the dataset, we select important features individually using all these techniques. So for complete data set, each technique will be applied individually and all the features they will be combined together. So here the selected features from various techniques are aggregated into a final feature set. After that, we split the data into training and testing sets, where training set is used to train the model and validation set is used to evaluate the model. Then we initiate all the machine learning models. We will be training them with the training data to learn the patterns from the data, and we evaluate all the machine learning models that are built in this project using accuracy, precision, recall, and FN score, and we compare through the graphs. Coming to the part of front end, so here a user-friendly interface is created using a Flask with features like registration and login supported by an SQLite database. And users they will be able to provide feature values as input, that is values related to attack, and it will be pre-processed at the backend. It will be fed with the trained model, and finally outcome will be displayed to the front end of the application. That is detecting the attack. So this is how we have implemented the project. Moving on to the algorithms used. These are the algorithms used in this project. So this is the extension model. And coming to the requirements, to implement this project, we need basically hardware and software requirements. So hardware are operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework Flask, back-end framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. So open the code folder which contains source code files. So these are the source code files in the code folder of the project. And here in this folder, we have the data set that is used in the project. Let's open it. So this is the data that we have used in this project. So here we have total 85 columns. I'll show you, just give me a minute. So here you can observe, right? There are total 83 columns present in this data set. 83 features we have in this data set. So we will be using all the feature selection techniques and select important features from this 83 features. And then train the model for predicting the attacks. Let's minimize it. Let's get back. And here in the static folder, we have CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And then comes the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the model file in which we have algorithm information stored, and that will be loaded into the project code during runtime of the application. This is the notebook.ipynb file. This is a Jupyter notebook file which contains combination of code, graphs, and outputs all in one place. And this is the sample file in which we have test cases that we will be using in the front end. And this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. So copy it. Now open the Anaconda prompt. So here it has been opened. Give the command cd, give the space, paste the copied path, and now click on enter. Here, if you observe, current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port. This is the local host and this is the port. So copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser. This is developed using Flask framework. So now let's get signed up. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so let's log in. Click on login. Give your username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. So initially we had 83 features, right, in the data set. So here are the 40 features that we will be giving as the input. So these are the selected important features. So we are supposed to give these features as input for predicting the attack. So let us understand what are these parameters are. So the first parameter we have is the source port. It is the source port number from where the connection is initiated. Then we have protocol. It is the protocol used for communication, that may be TCP, UDP, etc. Then we have timestamp. So it is a specific timestamp, that is the time the traffic flow was recorded. Then we have flow duration. So it is the total time duration of the network flow. Then we have total forward packets. It is the total number of packets sent in the forward direction. Then we have flow IET mean, flow IET max, flow IET standard deviation. It is the inter-arrival time statistics. It is the mean, standard deviation, and maximum for packets in the flow. Then we have forward IET total, forward IET mean, forward IET max, forward IET standard deviation. So it is the inter-arrival time statistics, that is the total mean, standard deviation, maximum for packets in the forward direction. And then we have PSH flag count, that is the count of packets with PSH, that is push flag set, which forces the data delivery without waiting for buffers to fill. Then we have down up ratio. It is the ratio of data sent in backward direction to the data sent in the forward direction. Then we have initial forward win bytes. It is the initial size of TCP window in bytes for forward direction. Then we have forward segment size min. It is the minimum segment size in the forward direction. Then we have ideal min, ideal standard deviation, ideal max. So it is statistics of mean, standard deviation, maximum of idle time between packets in the flow. Then we have flow bytes. So these are the flow bytes, total bytes transferred per second in the flow. Then we have flow IET min. So this is the flow IET min that we have. It is the minimum inter-arrival time for packets in the flow. Then we have forward IET min. So it is the minimum inter-arrival time for packets in the forward direction. Then we have backward IET total, backward IET mean, and backward IET max. So these are the inter-arrival time statistics, that is total, mean, standard deviation, maximum, minimum for packets in the backward direction. Then here we have backward min. So it includes in this only. It comes under statistics. So here we have idle min. So it is the minimum idle time between packets in the flow. Then we have source port and destination port. So these are the source and destination IP addresses of the traffic flow. Then we have destination port. So it is the destination port where the connection is directed. Then we have flow packets. It is the number of packets sent per second in the forward direction. Then we have total backward packets. It is the total number of backward packets, packets sent in the backward direction. Then we have URG flag count. So it is the count of packets with URG, that is urgent flag sent, indicating priority data. Then we have backward packets. So it is the count of packets with, it is the number of packets sent per second in the backward direction. Then we have packet length var, that is variance. So it is the packet length statistics, that is variance in the flow. So here we have packet length variance. And here we have packet length max. It is also the statistics of packet length. Then we have active mean, active max, and active min. It is the statistics, that is mean, maximum, minimum of active periods during which packets are being transmitted. So this is all about this 40 parameters. Now let us enter them. For that, we are supposed to open the sample file. So let's open the sample file in which we have test cases. So these are the test cases that we are supposed to enter now. So let's apply filter to the target class. Here total we have 6 different classes. Let's apply filter to class 0. Click on OK. And now let's enter the values. So here the first value source port we have is 6633, and then protocol is 6, timestamp is 3458, flow duration is 98, and then we have total forward packets. We have entered some wrongs. So here flow duration is 3028193, and the next value is 98, that is total forward packets. And then we have total IAT min, so copy it. Then we have flow IAT standard deviation, that is 712661. And then we have flow IAT max, flow IAT total, then we have forward IAT mean. So similarly, let's enter all the values. So I have entered all the parameters here. You can observe, right? So I have entered all the parameters. Now click on predict. So this given information, it will be pre-processed at the backend, and then train model will be giving us a prediction. So here we can observe that there is an attack detected, and that attack type is botnet attack. So here botnet attack has been detected. Now let's try with the other class. Click on prediction. Let's apply filter to class 1. Click on OK. Now let's enter the values. So where source port is 65193 and protocol is 6, timestamp is 4033, flow duration is 17, total forward packets are 1, and the next value is 17, 0, 17, 0, and then the next values that we have is we are supposed to enter forward IIT mean. So here we have forward IIT mean is 17. Sorry, it is 0. It is 0. And then we have standard deviation also 0. And then we have forward IIT max, it is 0. PSH count is PSH flag is 1. Down up ratio is 1. Initial win bytes are 1024. Forward segment size is 24. Idle min is 0. Then we have 0, 0. Then we are supposed to enter flow bytes, right? So that is 0. Min is 17. Forward IIT min is 0 again. So we have zeros up to idle min. So let's enter zeros up to idle min. And then SRC port is 58. And then we have destination port is 532. And then we have destination port. We have entered destination IP, then we are supposed to enter destination port, that is 9913. So I have entered all the rest values also. You can observe, right? Now click on predict. Here we got the prediction that there is an attack detected, and that attack type is brute force attack. So your brute force attack has been detected. Now let's check with the class 2. Apply filter to it. Now click on prediction. And let's enter the values where source port is 0, protocol is 0, timestamp is 3422, flow duration is 2, total forward packets are 5, IAT min, that is flow IAT min is 0.5, and then we have flow IIT standard deviation, that is 0.577. And then we have next value as 1. So it is 1 standard deviation. If you have missed some value, just wait. So 0. So here we are supposed to enter 0. So let's enter 0. Timestamp is 3422. Flow duration is 2. Total forward packets are 5. And IIT mean is, so IIT mean is 0.5. And then we have IIT standard deviation copied, that is 0.57. And then forward flow IIT max, it is 1, 2, 0.5, 0.57 again. And then PSH flag count. Let's enter all the values. So I have entered all the rest values also. Now let's click on predict. Here we got the prediction that there is an attack detected and that attack type is DDoS attack. So your DDoS attack has been detected. Now let's check with the class 3, apply filter to class 3. And let's enter this case. So I have entered all the parameters. Now click on predict. So here we got the prediction that there is an attack detected and that attack is malware attack. So here malware attack has been detected. Now let's check with the class 4, apply filter to the class 4, click on OK. Click on prediction. So I've entered all the parameters here. Now let's click on predict. And here we got the prediction that there is no attack detected. It is normal. So here there is no attack in this data flow keys. Now let's check with the last class label, apply filter to class 5, click on OK. And now let's enter the values, click on prediction. So here I have entered all the values. Now let's click on predict. So I've entered all the values. So let's click on predict. Here we got the prediction that there is an attack detected and that attack type is web attack. So here you can observe that web attack has been detected. So this is how you need to execute. Now let's check with the graphs. Click on graph. So here the first graph which you have is the sample outcome graph. This is the sample outcome graph which shows the class distribution of the target variable. Here on x-axis we have all the attacks and on y-axis we have count of each attack. And this is the correlation matrix graph. This is the accuracy comparison graph. This is the precision score. This is the recall score comparison and this is the FN score. Now click on sign out. In this way, just by giving feature values to the application based on the given feature value, the application will predict whether there is an attack or not. If there is attack, it will detect which type of attack it is. If there is no attack, it will show that there is no attack. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.